In this lesson, we're going to have a look at the families of cubic functions. In particular, how we're going to find the rule of a cubic function from a given piece of information. So let's jump straight into the first example. So we've been given a cubic function has the rule y equals a times x minus 2 to the power of 3 plus 2. So the only item missing in this rule is the value for a, which we know that it's the dilation factor of the cubic function. Now to find the value of a, they've given us another piece of information in this question. They're saying that the point 3, 10 lies on the graph of the function. So what we're going to do now is we're going to substitute the point into the rule and find the value for a. So let's start by substituting the value for x as 3 and y as 10 into the rule of the function. So 10 equals a times 3 minus 2 to the power of 3 plus 2. Right, simplifying that, 3 minus 2 is 1, 1 to the power of 3 is 1, which leaves us with a plus 2. Solving for a, subtracting 2 to both sides, gives us the value of the dilation factor as 8. So in this question, they're just asking us to stop by finding the value for a. So we could leave the answer the way it is. In another case, what they might ask you to do is they might ask you to find the function of the cubic function. So the only additional step we need to do in that case is basically write the rule with the correct value for a as a statement. Right, and that will complete that question. So we found the rule of the cubic function, including the value for a. Now let's have a look at another example. Right, in the second example, they've given us the rule of a cubic form. Y equals a times x minus 2 times x plus 2 times x minus 4. Right, so just looking at the rule, I can see that this cubic function has 3 x-axis intercepts. And again, the value that is missing is the value of the dilation factor. Now, like the previous example, they've given us a point to find the value. So we're going to start by substituting the point into the rule. So we're going to go 16 equals a times 5 minus 1, 5 plus 2, 5 minus 4, right, which gives us 16 equals a times 4 times 7 times 1, 16 equals a times 28, right, dividing both sides by 28, right, gives us the value for a as 16 on 28, which we know can be simplified further. Right, 4 goes into 16 4 times, 4 goes into 28 7 times, which gives us the value for a as 4 on 7. Right, and again we can choose to rewrite the rule with the value for a, so which means y equals 4 on 7 times x minus 1 times x plus 2 times x minus 4. And that completes that question there. Right, let's look at another example. Now in this particular case, we have the rule of the cubic function where we have two items missing, right? The coefficient of x cubed and the coefficient of x. They're both given by alphabets a and b. Now because there are two items missing, they've given us two pieces of information in this question. They're saying the points 1, 16 and 2, 30 lie on the graph of this function. So we're going to start by substituting both the points into the equation. So substituting 1, 16 into the rule gives me 16 equals a times 1 cube plus b times 1. Right, if I simplify this further, I'm going to get 16 equals a plus b. I'm going to call that as equation number 1. Right, substituting the second point, I'm going to have 30 equals a times 2 to the power of 3 plus b times 2. Right, simplifying that gives me 30 equals 8a plus 2b. I'm going to call that as equation number 2. Right, so we have two missing variables and we have two equations, obviously taking us to simultaneous linear equations. Right, so I'm going to multiply the first equation by 2. Right, which gives me 32 equals 2a plus 2b. Right, I'm going to rewrite the second equation just below that. 30 equals 8a plus 2b. If I subtract the two equations, I get 2 equals minus 6a. Right, 2b's and 2b cancels out, so it leaves me with minus 6a equals 2, which gives us the value for a as minus 2 on 6, or in a simplified version, a minus 1/3, right? And that gives us the value for a. Right, we still need to find the value for b, so I'm going to substitute this back into equation 1. So where a plus b equals 16, now a is minus 1/3. Right, adding 1/3 to both sides, b is going to be equal to 16 plus 1/3. So, right, fractions having different denominators. Right, if I make the denominators the same, I'm going to get 48 plus 1, which gives me 49 on 3. And that completes the question by finding the value for a and b. Right, and again, because the case has only 2 missing alphabets, the expectation is that this question is done without the help of a CAS calculator. Right, moving on, let's have a look at a question where instead of information given as a statement, they've given us the information in the form of a graph. So in the very first graph that I can see that there are 2 x-axis intercepts, and because one of the intercept is a turning point, I can assume that that particular x-axis intercept is a repeated factor. Right, the other one is a minus 1, so that's going to form a bracket of x plus 1. Right, so the rule I'm going to have is y equals a times x plus 1 times x minus 2 to the power of 2. So again, 2 x-axis intercepts, one of which is a repeated factor. Now again, I'm missing the value for a, and I have another piece of information in the graph to find the value for a, and that information is the value of the y-intercept. I can see that the y-intercept is 2, right? So I'm going to substitute the y-intercept into the rule. So I'm going to have, bear with me for a second, just going to fix that. Right, so I'm going to substitute the y-axis intercept into the rule. So 2 equals a times 0 plus 1, 0 minus 2 to the power of 2. Right, so 2 equals a times 4. Right, if I divide both sides by 4, I'm going to get a equals 2 on 4, which is same as writing 1/2. Alright, so which means in this case, if you notice, let's go back to the question. Right, the question is asking us to determine the rule of the cubic function. Right, so which means I need to rewrite the rule with the value for a. So the complete answer is going to be y equals 1/2 times x plus 1 times x minus 2 to the power of 2. Alright, and that completes that question there. Now let's have a look at the second graph. Right, the second graph I can see is a negative cubic function. Alright, starting to go down first from left to right. And I also notice this equation actually has a point of inflection at minus 1, 2. So when we have a point of inflection, we have to take into account the rule to be written in the format of a times x minus h to the power of 3 plus k. Now in this case, the point of inflection is minus 1 and 2, so which means the value for h is minus 1 and the value for k is a positive 2. So I'm going to use that into the rule. So a times, now because I already have a negative inside the bracket, so x minus negative 1 is going to become x plus 1 to the power of 3, and then the plus 2 for the k. So to solve the value for a, they've given us another piece of information in the graph. They're saying the graph passes through 1, minus 2. So I'm going to substitute that into the rule that I have. So substituting 1 and minus 2. So I'm going to have minus 2 equals a times 1 plus 1 to the power of 3 plus 2. Right, which gives me minus 2 equals a times 8. So 8a plus 2. Right, solving for a, so minus 2 on both sides. Right, gives me minus 4 equals 8 times a. Right, dividing both sides by 8 gives me the value for a as a negative half. right? So which means the complete rule of the cubic function is going to be equal to minus 1/2 x plus 1 to the power of 3 plus 2. And again, as we discussed at the start, the value for a equals -1/2, which proves correct because the graph is of a negative cubic function. And with that, we complete the lesson for cubic functions. The one last bit when it comes to finding the equation of a cubic function is when the rule is in the format or the general format, which in this case is ax cubed plus bx squared plus cx plus d. Now in this case, as we noticed, there are 4 missing items in this rule: a, b, c and d, right? And to work out all the 4 values, they've given us 4 pieces of information into this question, right? So in other words, what we're going to end up having is we're going to end up having a scenario where we're going to have a set of 4 simultaneous linear equations to solve. So in this particular case, we are going to be using our CAS calculators to solve the problem, right? So we're going to start by opening up a calculator page in the CAS calculator, right? And I'm going to go into Menu, Actions, Define, and I'm going to define the polynomial. So a times x to the power of 3 plus b times x to the power of 2 plus c times x plus d. Right, so we've done by the first step by defining the polynomial into the calculator. Right, so I'm going to go back to the question in a second. Right, so the question states the value for the function when x is equal to 1 is 0. The value of the function when x is equal to 2 is -7. The value of the function when x is equal to 4 is 27, and when x is equal to 5, the value of the function is 80. So I'm going to go back to my CAS calculator, and I'm going to go into Menu. I'm going to go into Algebra, Solve System of Equations, and Solve System of Equations. Right, now as we know that we are finding 4 missing items, which means we're going to have 4 equations to deal with. Right, and I'm going to replace the alphabets with A, B, C and D because those are the 4 missing alphabets we're trying to find. So I'm going to click on Enter, right, which gives me the solve function with 4 missing brackets. Right, so we're going to start by entering the first equation. The first equation is when the value for x is 1, the function is equal to 0. Right, so we're going to enter it by going p of 1 equals 0. Now the good thing about defining the function is we don't actually have to type the whole thing in, we just have to type it in this particular format. Right, the second point we're going to substitute is when x is equal to 2, it's -7. So p of 2 equals -7. Right, when x is equal to 4, it's 27. 4 is 27. Alright, made a mistake there. I've got to come outside the bracket. Equals 27. And when x is equal to 5, it is equal to 80. So I'm just going to double check that. Right, once I've finished entering all the 4 statements, I'm going to press enter, and my calculator is going to give me the values for A, B, C and D. Alright, so I'm going to go back to the document that I was using. Right, so solving using the CAS calculator, I get the value for A is 1, B is 1, the value for C is -17, and the value for D is 15. Right, so I'm going to rewrite the function with the value. So f of x is going to be equal to x cubed plus x squared minus 17x plus 15. And right with that, we're going to complete that question. Right, when we have a scenario where we have 4 missing alphabet, in most cases we will be using our CAS calculators to solve for the missing alphabets. Right, with that we complete our lesson for today. Thank you for listening and have a wonderful day.